ML enthusiasts, welcome back to another power-packed episode. I'm your host, Wisdom Bird, and today we're diving deep into one of the most crucial topics for your AWS Certified Machine Learning Engineer Associate exam, the MLA-C01. If you've been feeling overwhelmed by the sheer number of SageMaker built-in algorithms, don't worry, I've got your back. Think of me as your ML algorithm GPS, helping you navigate through this maze without getting lost in the technical jargon. What we're covering today: 18 essential SageMaker built-in algorithms, when to use each algorithm, exam gold, real-world applications that'll blow your mind, pro exam tips that could make or break your certification. Before we start our algorithm adventure, let me ask you this. Have you ever tried to choose a Netflix show when there are just too many options? That's exactly how many people feel about SageMaker algorithms. But here's the secret. Once you understand the why behind each algorithm, choosing becomes as easy as picking your morning coffee. The MLA-C01 exam has 65 questions with a passing score of 720 out of 1,000, and you've got 170 minutes to prove your ML engineering prowess. Data preparation holds the highest weight at 28%, but understanding these algorithms is absolutely crucial for success. Exam tip number 1, AWS loves scenario-based questions. They won't ask, what is XGBoost? Instead, they'll say, a company needs to predict customer churn with historical purchase data and categorical features. Which algorithm would be most appropriate? See the difference? Linear learner, the straight A student. Let's start with the algorithm that's as reliable as your favorite coffee shop. Linear learner. Think of linear learner as that friend who always finds the most direct route. It literally draws a line or hyperplane through your data to make predictions. But don't let its simplicity fool you. This algorithm is a workhorse. What it does: fits a line to training data for both regression and classification, uses stochastic gradient descent, fancy words for smart guessing and improving, automatically normalizes your data, one less thing to worry about. Perfect for binary classification, yes, no, spam, not spam, multi-class classification, dog, cat, bird, linear regression, predicting house prices. Exam tip number 2, linear learner shines with large data sets and when you need fast training. If you see a scenario with millions of records and need quick results, linear learner is your friend. Real-world example. An e-commerce company wants to predict if a customer will click on an ad based on their browsing history. Linear learner can process millions of customer interactions quickly and efficiently. XGBoost, the overachiever. Now, let's talk about the algorithm that's like having a team of detectives working together. XGBoost, extreme gradient boosting. Imagine you're trying to solve a mystery, and instead of relying on one detective, you have a whole squad. Each detective learns from the mistakes of the previous ones. That's XGBoost in a nutshell. The magic behind XGBoost: builds decision trees sequentially. Each new tree corrects errors from previous trees, uses gradient descent to minimize loss, works for both classification and regression. Why XGBoost is exam gold? XGBoost is an implementation of gradient-boosted trees that combines an ensemble of estimates from simpler and weaker models. It's incredibly popular in real-world ML competitions and production systems. Exam tip number 3. XGBoost is your go-to for structured tabular data with mixed feature types. If you see a scenario with customer data, sales figures, or any tabular data set, XGBoost is often the right answer. Gotcha moment. XGBoost can overfit if you're not careful. Always remember regularization parameters in exam scenarios. LightGBM, the speed demon. Meet LightGBM, the algorithm that's like XGBoost's faster, more efficient cousin who went to the gym. LightGBM is a popular and high-performance open-source implementation of gradient-boosting decision trees. What makes it special? 2 secret weapons: gradient-based one-side sampling, GOS, smart data sampling that focuses on important instances, exclusive feature bundling, EFB, bundles sparse features to reduce training time. Perfect scenarios for LightGBM: large datasets where training speed matters, classification, regression, or ranking tasks. When you have sparse features, lots of zeros in your data. Exam tip number 4. If an exam scenario mentions large dataset plus training time constraints plus categorical features, LightGBM could be your answer. SeqSeq, The translator seek-to-seek is like having a brilliant translator who understands context, not just individual words. This algorithm is specifically designed for sequence-to-sequence tasks, where you input one sequence and get another sequence as output. Powered by RNNs, recurrent neural networks, CNNs, convolutional neural networks, attention mechanisms, the secret sauce. Perfect for machine translation, English to Spanish, text summarization, long article to short summary, speech to text conversion. Exam tip number 5. See keywords like translation, summarization, or speech to text. Seek-to-seek is likely your answer. DeepAR, the time traveler. DeepAR is your crystal ball for time series forecasting. Think of it as an algorithm that can look at patterns in time and predict the future. What makes DeepAR special? Uses RNNs for one-dimensional time series, can train on multiple related time series simultaneously, finds frequencies and seasonality automatically. Probabilistic forecasting gives you confidence intervals. Perfect scenarios: sales forecasting, demand planning, resource utilization prediction, any scenario with time-dependent data. Exam tip number 6. DeepAR is the only SageMaker built-in algorithm specifically designed for time series forecasting. If you see time series in the question, DeepAR is often the answer. Text and language processing masters, the word wizard. Blazing text is like having a linguistic genius who can both understand words and classify text at lightning speed. This algorithm has 2 superpowers. Superpower 1, text classification, predicts labels for sentences. Sentiment analysis, positive, negative, neutral. Topic classification, spam detection. Superpower 2, word2vec, creates vector representations of words, captures semantic relationships, king, man's, woman, queen type magic. Exam tip number 7. Blazing text offers 2 different modes. Make sure you understand which mode fits the scenario. Text classification, supervised learning, need labeled data. Word2vec equals unsupervised learning, no labels needed. Real-world magic. A social media company uses blazing text to automatically categorize customer support tickets and create word embeddings for sentiment analysis. One algorithm, double the power. Neural Topic Model, NTM, the document detective. NTM is like a super smart librarian who can organize thousands of documents into meaningful topics without reading every single page. How NTM works its magic? Uses neural variational inference. Sounds complex, but think smart clustering. Organizes documents into topics automatically. Unsupervised learning, no labeled examples needed. Key requirement: words must be tokenized into integers, convert text to numbers first. Perfect for document classification, content recommendation, research paper organization, legal document categorization. Exam tip number 8. NTM versus LDA comparison questions are common. Remember, NTM uses deep learning, LDA doesn't. NTM is newer and often performs better on large datasets. LDA, the classic topic hunter. LDA, latent Dirichlet allocation, is the wise old sage of topic modeling. Been around longer than NTM, but still incredibly effective. What makes LDA unique? Not a deep learning algorithm, traditional machine learning. Groups documents based on shared word patterns. Can be used for clustering beyond just text. More interpretable than NTM. Versatile applications, topic modeling in documents, customer segmentation, group customers by purchase patterns, market research analysis. Exam tip number 9, LDA is more interpretable and works well with smaller data sets. If the scenario emphasizes interpretability or understanding the topics, LDA might be preferred over NTM. Section 3, Computer Vision Champions. Object detection, the scene analyst. Object detection is like having superhuman vision that can spot and identify every object in a scene simultaneously. What it does, identifies all objects in an image, provides bounding boxes around each object, gives confidence scores for each detection, can classify multiple objects per image. Available flavors: MXNet variant, TensorFlow variant. Training options: train from scratch, need lots of data. Transfer learning, use pre-trained models. Exam tip number 10, object detection versus image classification confusion. Remember, object detection equals where and what. Bounding boxes labels. Image classification equals what? Just labels for the whole image. Real-world scenario. Autonomous vehicles use object detection to identify cars, pedestrians, traffic signs, and road obstacles simultaneously for safe navigation. Image classification, the picture categorizer. Image classification is like a smart photo organizer that can instantly tell you what's in your pictures. Key characteristics. Assigns labels to entire images, doesn't specify object locations, supports both MXNet and TensorFlow. 2 training modes, full training and transfer learning. Perfect for medical image diagnosis, quality control and manufacturing, content moderation, product categorization. Exam tip number 11, transfer learning questions are popular. Remember that transfer learning is faster and requires less data because you're building on pre-trained models. Semantic segmentation, the pixel-perfect artist. Semantic segmentation is the Michelangelo of computer vision. It paints every single pixel with perfect precision. What makes it special? Pixel-level object classification. Creates segmentation masks. Distinguishes between different instances of the same object class. Provides shape information. Critical applications. Self-driving vehicles. Road versus sidewalk versus car. Medical imaging, tumor detection. Satellite imagery analysis. Augmented reality. Exam tip number 12. 3-way comparison questions are common. Image classification equals whole image labels. Object detection, bounding boxes, labels. Semantic segmentation, pixel-level labels. Random cut forest, the anomaly hunter. Random cut forest is like having a security guard with perfect memory who can spot anything unusual instantly. Amazon's secret weapon, developed by Amazon, proprietary algorithm, unsupervised anomaly detection, works especially well with time series data. What it catches: unexpected spikes in data, breaks in periodicity, pattern changes, unclassifiable data points, system failures, and fraud. Exam tip number 13. Random cut forest is Amazon's proprietary algorithm. If you see anomaly detection in time series data, this is often the preferred answer over generic algorithms. Real-world magic. Netflix uses anomaly detection to spot streaming service outages before customers even notice them. Object2Vec, the universal embedder. Object2Vec is like Word2Vec's incredibly talented sibling who can create embeddings for anything. Generalized power. Creates low-dimensional embeddings for high-dimensional objects. Works with any type of object, not just words. Finds relationships between different types of entities. Amazing applications. Computing nearest neighbors. Cluster visualization. Genre prediction for movies. Recommendation systems. Customer product relationship mapping. Exam tip 14. Object2Vec is supervised learning, but often the relationship labels can come from natural data patterns like user clicks or purchases. Don't get confused by the supervised aspect. K-means, the group organizer. K-means is the ultimate party planner. It can organize any crowd into perfect groups. Simple but powerful, divides data into K-clusters, groups similar items together, uses Euclidean distance for similarity. Unsupervised learning. Perfect for customer segmentation, market research, image compression, data preprocessing. Exam tip number 15. You need to specify K, number of clusters, beforehand. Elbow method questions might appear for choosing optimal K. KNN, the friendly neighbor. KNN, K nearest neighbors, is like asking your K closest friends for advice. How it works. Classification, majority vote from K nearest neighbors. Regression, average value from K nearest neighbors. Non-parametric, doesn't assume data distribution. Lazy learning, no training phase. Exam tip number 16. KNN is simple but can be computationally expensive during prediction. Good for small to medium data sets. PCA, the dimension reducer PCA, principal component analysis, is like a master of organization who can pack your entire closet into a single suitcase without losing the important stuff. Dimensionality reduction magic projects high-dimensional data to lower dimensions. Minimizes information loss. Components ordered by variability. First component has largest variability. Perfect for data visualization, noise reduction, feature extraction, pre-processing for other algorithms. Exam tip number 17. PCA is unsupervised and often used as a pre-processing step. If you see reduce features plus maintain information, think PCA. Section 5. Specialized problem solvers. Factorization machines. The sparse data specialist. Factorization machines are like detectives who can find hidden connections in sparse data. Specialized for sparse data scenarios. Click prediction. Recommendation systems. Pairwise feature interactions. Why it's special. Designed specifically for sparse datasets. Captures feature interactions efficiently. Supervised learning, classification, or regression. Exam tip number 18. If you see sparse data, click prediction, or recommendations with limited interaction data, factorization machines is likely the answer. IP Insights, the security guardian. IP Insights is like having a cybersecurity expert who can spot suspicious login patterns from across the globe. Unique capabilities. Unsupervised learning for security. Learns latent vector representations. Maps entities, users' accounts to IP addresses. Detects anomalous IP behavior, perfect for fraud detection, security monitoring, login anomaly detection, resource access patterns. Exam tip 19. IP Insights is very specialized. If you see security scenarios involving IP addresses and anomalous behavior, this is your algorithm. Section 6, quick reference and exam tips. Algorithm decision tree. Let me give you a mental framework. Think of it as your algorithm GPS. Step 1, what's your learning type? Supervised, have labels, linear learner, XGBoost, light GBM, etc. Unsupervised, no labels, K-means, PCA, random cut forest, etc. Step 2, what's your data type? Tabular structured, XGBoost, light GBM, linear learner. Text, blazing text, NTM, LDA, seek-to-seek, images, object detection, image classification, semantic segmentation, time series, deep AR, sparse, factorization machines. Step 3, what's your specific goal? Classification, most supervised algorithms. Regression, linear learner, XGBoost, KNN. Clustering, K-means. Anomaly detection, random cut forest, IP Insights. Dimensionality reduction, PCA, Object-2Vec. Common exam traps and how to avoid them. Trap 1, confusing similar algorithms. XGBoost versus light GBM. Light GBM is faster, better for large datasets. NTM versus LDA. NTM uses deep learning. LDA is traditional ML. Object detection versus image classification. Detection finds locations class. Classification just finds class. Trap 2, missing the unsupervised clue. No labeled data available, unsupervised learning. K-means, PCA, random cut forest, NTM, LDA. Trap 3, ignoring scalability requirements. Millions of records. Equals think linear learner or light GBM. Real-time predictions equals consider simpler algorithms. Trap 4, overlooking data preprocessing needs. NTM requires tokenized integers. Linear learner auto-normalizes. Some algorithms handle categorical data better than others. Final exam power tips. Power tip number 1, create mental associations. Deep AR equals deeps AR. Auto-regressive equals time series. Blazing text, blazing fast text processing. Object-2Vec equals object version of Word-2Vec. Power tip number 2, know the AWS specific advantages. Random cut forest is Amazon's proprietary algorithm. All algorithms come with auto-scaling and parallelization. Built-in algorithms require no coding, just data, hyperparameters, and compute. Power tip number 3, practice cost optimization thinking. Training cost versus inference cost. Instance type selection. Spot instances for training. Power tip number 4, security and compliance. VPC configurations. IAM roles and permissions. Data encryption at rest and in transit. Wow! We've just journeyed through 18 powerful SageMaker algorithms together. Remember, the key to acing the MLA-C01 isn't just memorizing algorithms, it's understanding the why behind each choice. The demand for AI and ML specialists is expected to grow by more than 80% by 2030, so you're investing in an incredibly valuable skill set. Your homework for this week? Practice scenario-based questions for each algorithm. Create flashcards with algorithm. Use case mappings. Take practice exams focusing on algorithm selection. Build hands-on experience with at least 3 different algorithm types. Quick success formula. Understand the problem type first, match data characteristics to algorithm strengths. Consider practical constraints, time, cost, interpretability. Practice, practice, practice. Don't forget to hit that subscribe button and ring the notification bell. You won't want to miss it. Got questions about any of these algorithms? Drop them in the comments below, and I'll personally help you out. Remember, we're all in this ML journey together. Until next time, keep learning, keep growing, and keep pushing the boundaries of what's possible with machine learning. This is Wisdom Bird, signing off. Good luck with your MLA-C01 exam. You've got this. All right, folks, that's it for today. If you enjoy Wisdom Bird Talks Tech, don't forget to like, bookmark, and share. Your triple support is the biggest motivation for Wisdom Bird to keep going. Got a tech topic you want to hear about? Drop it in the comments. Wisdom Bird will cover it next time. See you in the next episode, where we'll keep chatting tech, talking people, and exploring the human warmth behind AI. I'm Wisdom Bird, the super smart bird flying with you on this tech journey.